Perovsky's.
Oh, there we go.
Welcome to the Hackaday Podcast. My name is Mike Stish. I'm editor-in-chief of Hackaday.
Hi, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 24. Today we'll be talking about mashing smartphone buttons, sound blastering, trash printing, and a ludicrous loom.
So what's been going on in the news this week, Mike?
Well, I gotta tell you, song lyrics and a spat between Google and another company. Did you hear about this one?
I saw that. That's fantastic. They hid something in Morse code it was like in the quotation marks or something, right?
Yeah, so basically there is a song lyrics website that noticed some lyrics that normally are wrong from an album. They're hard to hear. This company had gone to the artist and said, "Hey, what are you actually singing there?" And, they got the information right from the horse's mouth. And almost immediately after they had updated their site, they noticed that Google, when you Google the song, had the correct lyrics as well, which was kind of tipping them off that Google's sucking their lyrics off of their site and representing it as their own. And so they set out to catch them with a clever little gimmick.
Which I already spoilered for you. So you're just going to have to say what it is.
Yeah, so what this company, Genius.com, did is they took some song lyrics that they were going to post, and they changed the quotation marks between like the UTF-8 and the Unicode marks. And so they look very similar, but one of them is like slanted and one of them is straight up and down. To the human eye, they're close, but to a computer, they're completely different characters. And if you change them to dots and dashes in Morse code, they spelled out the word red-handed. Sure enough, they appeared on Google search, and Genius.com came out and said, "Hey, Google's ripping us off."
Yeah, and you notice there's all this claim about who owns the lyrics and things like this, and copyright law is a horrible mess. You'd think it would be the people who wrote the song who would own the lyrics. Anyway, I don't know what claim these guys have on it, but I love that they're hiding messages in Morse code.
It's like, well, how can we prove that they are, scraping our site and representing it as their own? And this is an excellent way to prove it. I can't believe they pulled it off.
Yeah, speaking of Morse code, actually, this is something I've been working on. I was trying to think about what I could do to write us some new Quick Hacks music.
Oh, yeah. Do you have something?
We'll see. We'll see. I have 3 or 4 different somethings. I'm not sure which one I like yet. All of them are based around a motif using QH for Quick Hacks in Morse code, and it's actually pretty nice rhythmically. It's da 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 da.
Yeah, I like it. That sounds great. And you were hiding steganographic things in the first few episodes of the podcast, and that kind of trailed off, right?
Oh yeah, that was really fun. Well, I don't know how many different ways I can do that. What did I do? I did Morse code in an early episode, and then I started doing spectral stuff a couple times after that. I'll have to think of something clever to hide our Hackaday promo spam somewhere in the post.
Well, I'm looking forward to hearing the new Quick Hacks music, because that sounds awesome.
Well, me too. One of the ones I wrote ended up turning into like a house music track, which is not the essence of Quick Hacks. So we'll see what happens.
All right, I have one other newsy thing we should talk about this week, and that is the sound of silent electric cars.
Beep, beep.
Smash. Yeah, I can't believe that I didn't hear about this one until now, because this is a European Union regulatory outline that's been around for a while, but it's just going into effect on the 1st of July, and that's new electric cars sold in the European Union need to make noise when they're traveling 20 kilometers per hour or slower. So Lewin Day wrote this one up. He looked into the spec and kind of talked about it. Of course, the funny thing about this is they haven't specified what sound it should make. They've just specified, the speeds at which it should make noise and the over-under on decibel level, like max and min. And then Lewin's got a few links to YouTube videos, because apparently some of these electric cars have already been doing this for a while, like the Nissan Leaf. And it totally sounds like the flying cars from the Jetsons.
That's exactly what I wanted to do.
Yeah. So, and you actually was it you that wrote the article on internal combustion engines that were making more noise than they needed to? Yeah.
And piping it into the cabin so that it sounds right, and adding to it out of the stereo so they would, it turns out everybody was doing it. The coolest one out of those was Porsche, who actually have a tube They actually have literally a hole between the engine compartment and the cabin, and then you can open it and close it so you get more or less engine noise in the cabin as you drive. I think that's awesome. But then all the cheaters, like the Mustang, where they're just like, we'll put Mustang-like engine noise into the stereo system.
That's the thing, is these car companies have already had practice making their cars make noise, so this really shouldn't be a big leap for them.
Right, exactly. I'm waiting for it to become like ringtones used to be, so you can download car noises to your car.
I mean, I get it. I drive a hybrid, and when you're going slow, the engine's not on and it's super quiet. I mean, our street doesn't have sidewalks on it, and so anybody walking on the street is on the street, and I can tell people don't hear me when I'm coming past them.
Yeah, the statistics in that one were outrageous. Like for blind people, and I think cyclists were the other basically injured party, they're actually tremendously dangerous. It was something like 35% of blind people have had a run-in or a near run-in with an electric car.
All right. Well, I think that wraps it up for news this week. Let's jump into our favorite hacks, Elliot.
All right, I'd like to start off. I've got trash printer directly uses recycled plastic. And this is a hack by Sam Smith. It's actually in the Hackaday Prize. I've picked this one because I've seen 3D printers aiming to use recycled plastics in a whole bunch of ways before, and frankly, always disappointing results. This one looks really great. Sam started off with the kind of precious plastic workflow, and I don't know if you've seen that, but it's a whole project starting with a kind of a grinder. It's like a trash shredder thing to cut up whole plastic into plastic chips. And then they have a bunch of other things you can do with it. So you can make an extruder to do injection molding. Sam, in this case, is taking the plastic chips that result and trying to put them into a 3D printer head.
I also really like the kind of system diagram that has been put together for this, that gives you a blow up of each part, how it fits into the system, and then also has like little information columns on the actual parts and the cost of them. It's a really good way to figure out what you're getting yourself into before you take on a build like this.
Yeah, what's really interesting about this is Sam isn't trying anything that's particularly novel. Like the nozzle and the heater and stuff is a wood drill auger, and a bunch of the other things that hackers have been doing to make kind of recycled plastic extruders. Except I have to say he gets better results than I've seen before, so it's really nice to see that. His real contribution looks like is going to be to this is just kind of documenting this process super well and making the extruder easy to replicate for other people. And I think that's where it gets really cool. I guess tangentially, I should also say that the 3D gantry that he's putting this on is a mostly printed CNC, which is a really cool device in and of itself. It's basically cheap metal conduit as the frame with a bunch of 3D printed parts, and it makes a really strong CNC machine. I've seen people do aluminum milling with these machines, and they look really good. If I were making a mill, that's exactly what I'd make right now. Anyway, go check this project out. He's got this whole ecosystem from the plastic grinder to injection molders and other things coming out of the precious plastic scene, but then he's also got what looks like a really good 3D printer going.
The one that I liked this week was modeling the classic 555 timer on a breadboard. This was written up by Tom Nardi, and it's a project that the Magic Smoke pulled off. People like to joke around on Hackaday about you should have just used a 555 timer. I like to go the other way. When I see 555 timers, I say, you could do that with an ATT 85.
Yeah, right.
But this actually shows you that 555 timer has a lot going on under the hood, and by breaking it out into more discrete components. Now, it's not completely just transistors, but it's a couple of logic chips, a dual op amp, and a quad NAND chip, combined with resistors, a transistor, and a capacitor in order to model how the most basic design of a 555 timer works.
That's what's kind of neat about the 555 is that it's this kind of bundle of functions all put in one chip, and so you can do whatever you want with it. it makes it a neat project to try to reproduce each of these functions individually using bare chips, because on one hand, by breaking it into parts and replicating the different parts, it kind of liberates you from the tyranny of the 555. On the other hand, it's a great dive into it. Yeah, I like the ones where they do it by transistor, but that's really just copying the data sheet. So I think he learned more in this one by trying to replicate it using other chips, other logic chips, and an op amp. It's a much more complicated circuit in terms of like transistor count than it would be if he'd gone the bare transistor way. But I think he learned more about it, and I think he learned how to replicate the stuff you would want to copy and implement yourself. So I love this project.
Yeah, so even just the choices on those two different chips for this, like if you haven't ordered these logic chips before, going and picking out exactly which one you're going to use and why for this project, and even greater is having an appreciation for the rock solid reliability of an IC, the 555 timer. It makes me think of trying to build your own oscillator and then trying to turn that oscillator into a real-time clock, and then trying to look at how that drifts over time and over temperature. It just gives you a lot of appreciation for, like a wristwatch that you basically don't lose or gain time on, or like one of those temperature controlled oscillator real-time clocks that are like 3 parts per million per year or something.
Yeah, right? Yeah, it's just one of these learn so much by doing it hacks, right?
Yeah.
Well, my next hack is multifaceted. This one is called Cycloid Drawing Machine Uses Sneaky Stepper Hack. And this combines a bunch of things I like all together. The Sneaky Stepper hack in question takes one of these dirt cheap 28 BYJ48 motors, which if you haven't played around with these, it's a unipolar stepper motor with a gearbox on it. And I think they're meant for driving like louvers in cars, or they're light duty stepper motors, but then they're geared down. So they're kind of useful, but because they're unipolar, they don't have much torque. And so a common hack is to open up the little box on them, cut a trace, and then drive them like a bipolar motor, where you get twice as long coils driving the motor. So you get a lot more torque out of it. That's something I highly recommend. I do that with 28 BYJ48s all the time. It turns them into a nice usable amount of torque for a small device. But the hack here is, instead of opening this silly little plastic box that's kind of hard to get open, Inventor Artist makes a little template showing you exactly where you need to drill, puts it on the little blue box, and then just runs a 1/4-inch drill through there, hitting the trace exactly without even having to take the thing apart. So it's I just love that idea, because I've done this now 4 times, 5 times with these stupid little motors, and taking the little blue box off is a pain in the butt. So I like the idea of just mark it, drill in. I think that's really, really clever.
When you pop up in one of those cases, do all the gears come apart?
No, thank God, no. But what happens is you pull the little tabs off the blue thing, and I can never get them to go back on. So you just end up with like a little circuit board dangling off the thing.
Oh, right. Yeah, so you have some tabs that go through holes in the board and kind of hold it in place.
Yep. And when they come out, I mean, every time I do it, I rip them and they never go back in. It's aesthetic. I mean, it's a cosmetic issue, but you might as well do something that looks nice and is simpler, which I think this is. But in the process, I went through Inventor Artist's previous drawing bots, and he's got a whole bunch of really cool ones. The one that's in the little animated GIF in this article has one of those scissor arms, like the Wile E. Coyote boxing glove thing. It's on the end of one of these, like, I don't know what that's called. Is it a scissor mechanism?
That's a good, you would call it a scissor lift if it was lifting people up in the air.
Exactly. It looks like a scissor lift, except it's horizontally and it's pushing the pen in and out. And this one's even weirder because the two ends of the scissor, the two back sides of the scissor, are attached to wheels of different diameters that turn. And then it's holding a pen on the end of the scissor, and then it's drawing on a rotating platform. It's an awesome little drawbot that makes kind of Spirograph Plus type drawings. But definitely go through Inventor Artist's website because he's been making these funny little draw bots a lot. In particular, I love his Artomatic, which is similar to this one, but you have to check out Isosceles Ease, which instead of using a scissor lift arm, uses two arms in isosceles triangle shape that are then driven back and forth across a linear rail. And so it kind of manipulates this triangle around to draw with. It's really, really clever design. I have no idea why you don't see these in other draw bots, but it looks really cool.
As far as I can tell, that is called a scissor mechanism, according to the knower of all things, Wikipedia.
Fantastic. It's a scissor mechanism. That's what I said.
Yeah,
scissor mechanism.
It has an animated drawing on the Wikipedia page that calls it a pantograph mirror, but I think a pantograph actually changes the distance traveled on one end or the other, and this I don't think does that.
Yeah, they're really cool. This one's just used to translate turny wheels into interesting harmonic motion.
All right, so this one is a deep rabbit hole for me this week. It comes out of the @TubeTimeUS Twitter channel, or actually the website tubetime.us, which is Eric Schlepfer's channel. The article written by Brian Benchoff is Reverse Engineering the Sound Blaster, and that's right. You can get a Sound Blaster 1.0 card built by you and put it in your computer and have it work now.
Just what I always wanted.
So it's crazy. You look at the silk screen on this, and instead of saying Sound Blaster, it says Snark Barker, which is an excellent playful name. And then right down by it's an ISA card, so it's got the finger edge connector copper down on the bottom, and it says Made in Anger on the bottom. So Eric found out that if you wanted to get one of these cards on the used market, it's prohibitively expensive. He decided to perform a service for all people everywhere in reverse engineering all of the components and how the circuit goes together and posting it to GitHub. So you can definitely build this yourself, down to a 3D printed wheel for changing the volume on the back of it. And but I think the better thing, I don't know that Brian linked this in the article. I don't think he did. I should add this in as an update. So shortly after announcing this, and I think it was back in January, Eric made another article that walks you through all of the different circuits on this card. And that's what I got bogged down in this week. And that's what you should spend your time looking at.
Oh, that's super cool, because I'm never going to make a Sound Blaster, but I'm totally want to see somebody walk through the circuit diagram of how one works.
Yeah, I'm sad that we missed this for so long, because I've actually seen Eric in person since he posted this, and I would have loved to talk to him about it. So I dug through to see if there was, more available, and found a few things. I thought it was really amusing in his GitHub assembly instructions. He tells you to remember to put the bodge resistor in, which spans over the top of a chip and connects two legs. I guess
right.
Missed a biasing resistor or something in there, and has a few other nice tidbits like that. I think the hex file, people were asking in the comments of the announcement article about the hex file if that was IP of Creative, and he said no, that is pulled down from a Chinese clone manufacturer, has that as a firmware upgrade file that does happen to work. Your only other option is to take one off of a non-working card. Right.
Yeah, I have to wonder about what all the different parts are and what their availability is.
Yeah, I didn't open the bill of materials on here.
I mean, it's an OPL, was it OPL2 or OPL3? But it's got one of these old sound synthesis chips on it. You're going to have to source that gem.
I saw him say something about that. You definitely can get that.
I've got a couple in my closet. If you're in Munich, you can come bother me.
Oh, interesting. Brian says in his article, prices on eBay now exceed $400, which is 2x what it would have cost at the time of release. Did you have one of these cards?
Did I ever have a Sound Blaster? I probably did, actually.
Yeah, I have trouble remembering. I remember the first time I figured out what a Sound Blaster was came from playing Doom, because it had actual Sound Blaster settings, and apparently that was the best you could get at the time, and I didn't have that, and I was like, what is that? Why don't I have that?
Exactly.
Do you remember what the opening song of Doom sounds like played through the PC speaker? Like the buzzer?
Oh no.
Oh,
I never had to suffer through that.
oh, it was a spectacular piece of horrible.
Oh man.
Uh,
Oh,
did I have anything else on here? Oh, this is the same Tube Time. You may remember them, or may remember Eric's work cutting common components in half so you can see what's inside of them, cutting and polishing and all that stuff. We kind of geeked out about that in the podcast, I don't know, a half dozen episodes or so ago.
yeah, he does great stuff.
I think the next one we had both had on our list, so I was happy to see you had grabbed it. It is a knitting project.
Oh, you had this one too. Cool.
Yeah.
This is Kurt Schaefer's project, open source computer controlled Loom knits Pikachus for you. This is a fantastically detailed but extremely difficult build. Hat off to Kurt Schaefer for this one. It is amazing. You have to watch his video. It's a very nicely made video. Frankly, it could use more detail for me, but it's amusing and well filmed. So, go enjoy that. It all starts with him giving his son a loom, and his son starts knitting, and he describes it in the video. He says, by the end of, he got this for Christmas, and 1 day or 2 days later, he's already got a winter scarf made out of this hand-driven loom. And so he thought, I'll make a computer-controlled loom. And then he spends the next year and a half making 3D printed and laser cut parts and working on the mechanism and all of this to make it work. Trouble after trouble after trouble, and he surmounts them all and gets the job done. So real serious kudos to just the raw effort on this one.
So I have to say I greatly prefer written content because I can get through it just so much more quickly than a video. And so I tend to skip around in videos, and I almost missed the really cool parts of this build. There is a square axle in the center of this cam system that has one portion of the axle that is exactly one cam's width that can rotate. And so this rod goes through this cam system and is able to change the orientation of the cams in order to change the pattern. I don't know the proper name of the strings that are permanently affixed in the loom and go up and down in like a comb-like fashion.
One's the warp and one's the weave.
Okay, yeah.
I think that must be the warp.
So this cam system can alter which ones are going up and which ones are going down, which is what starts to draw the pattern on it. And I just thought that was a really brilliant way of doing it until he started scaling up the number of the cams in this system, and friction became a huge factor. He had to do a redesign.
This is one of those things where you think you're going to be doing something simple. So for each thread, it's 6 or 7 little 3D printed parts. But then if you want to have this thing be 60 threads wide, all of a sudden you're looking at 560 small 3D printed parts. Scaling a loom up like this gets out of control very quickly.
Yeah,
rock and roll.
Since it's like rapid prototyping, even at that number of parts, I don't think it's worth trying to mold make.
Oh, that's an interesting question, though. I don't know either. I mean, if I had to do the molds one at a time, it would surely take me about as long as it would 3D printing. If you don't mind waiting, 3D printing is awesome, right? You just set the printer running and you come back a month later and you've got your 560 parts printed out.
Yeah, I mean, I suppose that's why it takes a year and a half.
Yeah.
All right, from textiles to cell phones. This next one is bonkers way to add different haptic inputs to your cell phone. So things like clicky buttons, scroll wheels, rocker wheels, kind of any physically moving button you can imagine. And it's done by adding a 3D printed case onto the back of the phone that has kind of a postage stamp sized socket that you can slide your different controls into. The article was by Dan Maloney called Add Scroll Wheels and Buttons to Smartphones with 3D Printed Widgets Read by Accelerometer. And it's about a research paper, and wait for it, you're going to groan, a research paper by researchers at Columbia University and Snap Incorporated, the people behind Snapchat.
Oh, really?
Yeah, interesting, right? The way that this one works is completely accelerometer based. And I could swear I had seen an article on Hackaday about using the accelerometer as like a spy device to tell something, like whether a room was occupied or maybe if people were speaking. I don't think it could actually be used as a microphone, but it kind of shocked me in how how much data you can actually get out of the accelerometer. And in this case, what the researchers are doing is if you have a button that clicks, if you think about like a clicky push button, when that click happens, it shakes the phone in just a certain way that's kind of like a fingerprint, and that can be detected and picked up by the accelerometer. Same with the scroll wheel. If you think about where the scroll wheel kind of has, I don't know if they call them gradations or like indented bumps, so it clicks a little bit as you scroll it. One of the demonstrations that they have is using the scroll wheel with your thumb to zoom in or out, so you don't have to try and pinch zoom when you're trying to hold a camera steady. Imagine taking a video and not having to pinch zoom in order to zoom in on something. All the hard things come to mind right away for me, like, well, that's totally not going to work if you're on the subway. Well, guess what? They actually talk about taking this on the subway and trying it out, and it still works with a few more false positives, but still, or I don't know if they're false positives or just like they missed reading a button press and that sort of thing. So I read the whole paper, and I think you would find it just as interesting as I did, and I think probably hackers could pull this off if you put your mind to it. It's a lot of math and smartphone app writing.
Yeah, when I read this one, I was like, I've seen something like this before. And I spent, I don't even know how long going through old Hackaday to find this article on acoustic barcodes, which I'll throw in the links here. And this I thought was a really clever early hack by some folks at, I think, Carnegie Mellon Human Interface Design. The idea is you cut lines spaced out differently into a piece of plastic, or you laser cut them onto the surface of something, or you 3D print little bumps, and then you run your fingernail or a pen or whatever across them. And the click, 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 click that it makes, you can use the timings of that to make something similar to acoustic barcodes. And so when I saw the scroll wheel and buttons thing, I'm like, oh, they're doing exactly the same thing, except with the accelerometer instead of the microphone. If you want to replicate something like this yourself, there's a bunch of different cool ways to do it. Like, one is to make switches like they do. Another would be to just do these little barcodes on the back of your phone. You could, scroll your fingernail up and down them and stuff. I think there's all sorts of great ideas here around this kind of accelerometer / textures to run things across and see how they can convey different information. But then this all pushes all of the heavy lifting off to the software on the phone. So you've got to get your accelerometer parsing and gesture recognition software on the phone just right.
Yeah, but man, to take advantage of that really high-end sensing hardware on the phone, I just don't think we're doing much with that right now. Yeah, caveats here, you can't like hold a button and scroll the scroll wheel. Stuff like that doesn't work because it's kind of like the vibration that goes through the phone from the button you push is a here and now thing. But software, you can fix a lot of things in software. It gets around.
We'll fix it all in software, says the hardware guy.
Yeah. The thing is, it gets around all of the like different models issues. Like you don't need to have a way to connect into a micro USB on one model or a USB-C on another model. You don't need a battery to do like Bluetooth. This is purely mechanical on the outside and using internal components that I don't think you're going to, find you have a lot of battery usage by reading the accelerometer more frequently. It's a small scale MEMS component. So I think there's literally no downside to doing more user controls with this.
Quick hacks.
Quick hacks.
All right, my quick hacks. Here we go. First up is Alex Shakespeare's Let a Spooky Owl Tell You the Weather. I love this one. It's a picture of an owl with kind of googly eyes that follow you as you walk around the room. It's also got some weather displays on it. There's nothing really particularly special about the weather displays. All the processing is done on a heavier computer, and then the data is sent to the ESP8266 that's driving it. It turns some servo motors. But the coolest part of this is the owl with its googly eyes, and they're driven on the back by magnets that couple to the googly eyes and built with a supreme popsicle stick mechanism. So you should absolutely go check this one out, and the effect is just delicious. The next one up is a 3D printing post. This is try Nopscad lib for your next OpenSCAD project. And I'm a super long time OpenSCAD user, and so is Nophead. And he put his library of parts together. If you don't know, he's the guy who designed the Mendel 90 3D printer, which came out just about the same time as the Prusa i3 and is a completely open design now. I've been using a bunch of Nophead's OpenSCAD functions for ages, and it's really cool that he's bundled them all up and put them in one place for you to use. So if you use OpenSCAD, go check out his website, go download the repo, and go browse through the readmes in there. It's absolutely fantastic. Finally, this one's not a project. In fact, it should have been a can't miss article last week, and we just can't let it go. This is our own Dan Maloney wrote up perovskites, not just for solar cells anymore. And this is covering a neat new bit of material science that will hopefully eventually make for more efficient solar cells. The chemistry is very beautifully explained in the article. And so while perovskite chemistry is kind of new and does look like it's going to have extreme promise in making solar cells, it also, when used as an X-ray sensor, will make a much more sensitive X-ray sensor, allowing you to do the same X-ray with a lower X-ray dose. Dan makes the point that there are lots of material science problems to work out in the solar cell market, which has a comparatively low margin, but we'll probably see these first in X-rays where it's medical industry equipment and there are high markups and extreme pressure to get the amount of X-rays going through people as low as possible.
My quick hacks this week start off with wireless mouse power up. Logitech MX Master gets USB-C and big battery, written by Tom Nardi. So this project was pulled off by CMOT17, who noticed that their wireless mouse battery was not doing well. These do have a lithium cell in there. It's not a huge one. It's about 500 milliamps. And this hack changes it out for a 950 milliamp battery, but at the same time converts the recharging port on the mouse to a USB-C. It's one of those hacks that you always look at and you think, man, can I do a little bit of an upgrade on this? But few people actually take the plunge. This one's a lot of fun to watch. It also gives me a little bit of hope that I will be able to pull off my ultimate goal with wireless mouse, which is turning them into supercapacitor powered wireless mouse. So we'll see if that ever happens. Next up on my list, another peripheral hack. This one is up your game with a battle-tested input device, also by Tom Nardi. And this is a Rockwell Collins keypad that you would find in a C-130 Hercules. It was bought on eBay. It was not scrapped from the plane itself. Well, I don't know where they originally got it, but this hacker, Melkor's Greatest Hits, gets it from eBay and ends up using a Teensy microcontroller in order to interface all of these buttons and connect it up with a flight simulator stick. It's really good looking and sits on your desk so that you can have a more inclusive, I think, helicopter simulation on this, but I might be wrong about that. And finally up, we have one of the best things I saw this year at Maker Faire Bay Area. This article is written by Roger Cheng, entitled Exquisite Craftsmanship Elevate Bix Creations Above the Rest. And this is Dr. Victor Cheney, who is a dentist by day, and I would say a museum piece grade hacker at night. Everything that he had at his booth looked fantastic, from musical instruments to an LED cube inside of a beautifully built acrylic box. But for me, I only had eyes for the marble run, which includes several automata golfers. And the marble will kind of go into the base of where this golfer is and come up through a hole beneath the golf club. And the motion back and forth with this golf club and the knees of the little golfer are so lifelike, but yet the mechanism is so simple. It will just make your day to look at this one. So go check it out. All right, Elliot, let's move on to the can't miss articles of the week. These are longer form articles written by the illustrious Hackaday writing crew. Which article did you like this week?
Sean Boyce's etching large brass sheets is harder than you think really tickled my fancy. I do a lot of home DIY etching but printed circuit boards, small things. In this article, Sean is trying to etch a sign. Basically, I think it's for a friend's wedding present, but that's not the point. The point is he wants to etch a huge chunk of brass so that he can make a sign in it. So the idea is you etch some of it away, you paint in the low spots, and you polish up the high spots, and you get this nice contrasty, old school sign kind of looking thing. It's a beautiful look. He gets problems scaling things up. So like all the things that you do for printed circuit boards are much harder when you're talking about a piece of metal that would take up most of your desk rather than just a little 20 by 20 millimeter printed circuit board. So he goes through a whole bunch of different procedures that don't work, sadly, before doing essentially a toner transfer like method, except you can't heat it with a clothes iron like I always do. He has to take this giant piece of brass and put it on a gas stove and get it heated up enough so that it can melt the toner onto the brass. I think that's an awesome solution. He is all full of cautions on this one. I don't think he burnt himself in the practice, but it probably pays to make sure that everything's stable when you're going to do the rolling of the toner transfer part before you heat things up. Because once it's hot, you've got a heavy piece of hot metal, and you don't want that falling on your toes. Anyway, as with all art processes, nothing's quite perfect on the first run. There's a lot of touch-up to be done, and he does some of that with UV curing acrylic, I guess from fingernail painting, and makes a nice solid resist, hits it up, and then paints it. And the paint is another experiment in itself, trying to find exactly the right paint to cover these low spots in the etched away brass. But I'll leave that to you to read in the article if you want to. The long and the short of it is that doing something on a larger scale like this, even if it's something you do all the time, like etch printed circuit boards, is harder than you think just because of scale and heat sinks.
When he really tried all possible available processes here, I was really surprised that the basic photoresist applications were giving him such trouble. And he mentions that one of the first problems he had was just bubbles underneath the resist, and it was happening even when he applied these underwater, which is, in my mind, that underwater application is probably how they're done at the industrial scale.
Man, I have no idea how they do that.
Yeah, I just, I equate it to putting on the wet application of a cell phone screen protector, where you apply a liquid in between the adhesive and the material, the surface you're adhering it to, and then you work the bubbles out before the adhesive is in place.
Yeah, but on a cell phone screen, that's small, right? So I've done the same thing, but on the heated bed of a 3D printer, and so that's 200 millimeters by 200 millimeters. And just simply the scale of things makes it much harder to do exactly the same procedure and get those bubbles out. Like anyone who's put grip tape on a long skateboard knows that it's hard to do too. Like things just get harder as you scale up. So I kind of believe it. Sean lives in Vietnam. It might just be a case of cheap Vietnamese photoresist. I actually can't speak to that at all. I've never used UV photoresist. I really should.
No, I've looked into it extensively because I was considering switching from toner transfer to this. This did not seem easier unless you use pre-sensitized boards, which would have taken care of most of the problems he's having with the photoresist. But, this is a huge piece of brass that he's going to mount to his front door. And so it's not really an option to get a pre-sensitized thing. You have to roll it yourself. I did like that he used paint to touch up on the toner transfer process, because I use Sharpie to touch up when I do board etching.
All the time. Oh yeah, the thing that I'm interested in trying out for myself is some of this UV acrylic, some of this UV nail acrylic. Because when I was reading his article, I couldn't help but think it'd be neat if you could spray that on to, the metal surface somehow and get a nice even coat by maybe spray painting it. And I wonder what kind of solvents you could use to thin that stuff out. So you could maybe get it into like an air sprayer or a spray gun or something, or even just paint it on thin enough that you could do it in multiple nice coats. That might be another alternative to using those sheets where you don't have to worry about the bubbles because you're just painting the stuff on.
Huh, interesting. What about vinyl resist? Can you put vinyl sticker on there and then put it through a laser cutter and weed it?
Yeah, you absolutely can. And if you have a laser cutter, a lot of this is problem solved already. The other way to do it, I guess, would be to just use any kind of paint and directly ablate that off. I know a bunch of people who use, like, it's a black Krylon heat resistant paint, but it ablates super well with a laser cutter. So you spray your thing with black Krylon and then you throw it in the laser cutter. And the laser cutter can't touch the metal because it's only like a 40-watt laser cutter or whatever, but it can totally eat up the black paint. And so you can do the etch resist that way. That'd be a great way for Sean to do this. I assume he doesn't have a laser cutter.
I wonder if anybody's doing UV laser to cure resist.
Yeah, that's what I would do. And so that's the reason I would want to do a UV curing resin, is because you can get near UV lasers that are fairly powerful, and you could just build a rastering device or even a vector 2D vector scanner to go over these. And we've seen a number of things like this on Hackaday for used with the pre-sensitized boards. Yeah, that's something I'd like to try out sometime. That's on my to-do list.
So many good ideas, so little time.
Tell me about it.
Well, speaking of good ideas, have you ever thought of building your own nuclear reactor at home?
All the time, man.
So Tom Nardi wrote an article this week called "You Wouldn't Download a Nuclear Reactor, But Could You?" Kind of.
Yeah, not really so much, actually.
Yeah. So this article is about a company called Transatomic, which was founded by a couple of MIT alum. And they were planning smaller reactors that could take what would be usually be considered waste material from larger reactors and continue to get energy around it and further break down that material, reducing our problems with, what do you do with the waste from larger reactors? Unfortunately, this company couldn't pull it all together, couldn't make it quite work for one reason or another, and went out of business in 2018. But before they did, they sought out the advice of the governing bodies for this sort of thing and said, hey, what do you think if we just post this stuff on GitHub? And sure enough, you can go and download the research work that they had for this. However, it's not quite a step-by-step process from zero to atomic fusion.
Yeah. A lot of these blueprints and patent filings and stuff like that are fairly sketchy. Tom says it in the article. He says, even if you go through everything they've got, you're probably not going to learn too much more than you already know about building a nuclear reactor. To a large degree, that's true. But what was interesting is there was also a lot of kind of licensing and regulatory documents in there that I wouldn't ever have the chance to see, not building nuclear reactors for my day job. So that's kind of interesting to see some of that stuff. But as far as the actual plans for the nuclear reactor go, it's just what you think. It's a lot of, how to deal with moving this water from here to there and where the valves for the cooling go and stuff like that. Kind of boring plumbing, if I can say it.
Well, the hard part, of course, is the fuel, which they were planning to get from waste materials from other reactors. You're not going to have access to that. It's kind of like if you can build an internal combustion engine, but you either need a source to buy fuel or you need a way to refine your own. And without those two things, it doesn't matter how great your engine is.
I guess that's right.
But I think the bigger picture for me on this is I like to see a couple things. One, when companies go out of business, I think your last ditch effort on the hard work having legs is to put that out there so that other people can benefit from it and see what was going on, no matter what working state it was in. I think it helps to disclose, like, hey, this doesn't work. Here were the problems that we had that we couldn't solve, so people know. But it lets people look and say, what are the minds of nuclear physicists doing when they start to look at new systems and start to design new things? And I look at some of what we've seen in the fuser hobby, which is, I guess you could say it's building a reactor in your basement. But we had an article just earlier this year about a 12-year-old who built a fuser, and that whole community of people who have done this themselves are willing to give advice and help people through it. And they also serve as people who verify that you actually did, you actually achieved what you were setting out for, and you kind of like join a club in that. And if you have a 12-year-old working on that, what's going to happen when that 12-year-old gets to college and then, gets an engineering degree and starts looking for problems that haven't been solved yet to attack? It's just a jump start on what we as a society can do, because the raw materials, the people that you need to solve these problems are so far along than those that came before them were at the same age.
I really liked reading that article about the 12-year-old builds successful fuser at home, because I went through that forum a little bit for, home fuser design, and was super impressed by all of the practical knowledge about how to do this safely. Because Tom in this article linked the radioactive Boy Scout article, and that one, he was playing a little bit fast and loose with the safety issues and got burned by it. And I take the radioactive Boy Scout story as a cautionary tale, saying, hey, look out. Building fusers can be really dangerous, and radioactivity is creepy, and you don't know how it's hurting you, and all of the above. So I love the antidote to this kind of fear and uncertainty that you get by reading this fuser forum, because they're talking about how to take the safety precautions and still make sure you get this nice, beautiful purple glow of fusion in your home.
We've seen kind of a proof of this before with homemade integrated circuits. So if you didn't see Sam Zalouf's talk from the Hackaday Super Conference in November, you should definitely go check that out. Also, Super Conference tickets are on sale right now. It's November 15th, 16th, 17th in Pasadena, California. Go to hackaday.com/super conference for more info on that. But I digress. So, Sam learned a lot from Jerry Ellsworth's videos on making your own semiconductors at home, and then also dug through a bunch of different books and had a hard time finding the knowledge needed to do a fully lithographic integrated circuit build at home with that equipment. And he's now going to college, and again, that same story, what's going to come out of his career? He's so much further along already. I mean, if you get a jump start on your PhD in, nuclear physics or in integrated circuit design when you're still in high school, that has major ramifications for what we can accomplish in one person's lifetime, and what we can do together as a society. These are all good things. I like to see this really difficult to come by knowledge made available, and in this case in a responsible way. Like we said, the company went to their regulators first and made sure that they were cool with it. Well, that's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes by going to hackaday.com/podcast. You can always get in touch with us, editor@hackaday.com. Until next week,
keep on hacking.
No, the whey goes down the drain. What do they do with the whey?
If I don't get my curds and whey, I'm not sitting on this tuffet.